Bridge in China could send your heart racing because it's the world's highest, and it opened today. It stands more than 1,800 feet above the valley below.
Well, it's too good to be true, but it's true that China holds the record for world's longest, massive, and greatest bridges of all time.
It links Hong Kong, Macau, and Zhuhai in mainland China, and it's one of the most ambitious engineering projects ever built.
This powerful nation is not just building bridges. It is moving people, goods, and culture to different areas. As a global leader, no wonder engineers in America are left in shock due to the mighty Chinese construction technology. Let's start crossing some of these bridges and get to learn their monumental building journey. The Danyang Kunshan Grand Bridge, a marvel of modern engineering. We'll begin with the best bridge out there, truly stretched out and massive. The Danyang Kunshan Grand Bridge, a colossal feat of engineering, is widely recognized as one of the most remarkable structures ever built. Spanning 164.8 kilometers, this bridge holds the title of the longest bridge in the world. Completed in 2010 and opened in 2011, it is a central component of the Beijing-Shanghai high-speed railway, one of the most important transportation networks in China. The bridge's design, scale, and impact on both society and the environment make it a true testament to human ingenuity and modern engineering. The sheer size of the Danyang Kunshan Grand Bridge is its most obvious and awe-inspiring feature. Stretching over vast expanses of water, wetlands, and mountainous terrain, the bridge is an unparalleled structure in terms of length. It surpasses any other bridge globally, earning its place in the record books. The construction of the bridge required meticulous planning, precision, and coordination, with thousands of workers and engineers working tirelessly for several years to complete it. The scale of the project posed significant challenges, but its completion stands as a testament to the capabilities of modern civil engineering. What makes the Danyang Kunshan Grand Bridge particularly impressive is not just its size, but also the advanced engineering and design that went into its construction. Built to withstand extreme weather conditions, including earthquakes, floods, and strong winds, the bridge incorporates cutting-edge technology and innovative techniques. Its foundation was specially designed to adapt to the varying conditions of the terrain it crosses. The bridge spans large bodies of water, areas of soft ground, and even mountainous regions, making its design and construction especially challenging. The use of prefabricated sections, advanced cranes, and high-tech materials helped make the project possible, ensuring both durability and efficiency. The bridge is composed of several segments, each carefully constructed to meet the specific challenges of the environment. The bridge is supported by a combination of viaducts, embankments, and elevated sections that allow it to traverse such a wide and varied landscape. The structure's design incorporates features that ensure the safety and longevity of the bridge, including anti-corrosion materials and reinforced supports that can endure the test of time. Beyond its impressive engineering feats, the Danyang Kunshan Grand Bridge plays a crucial role in China's high-speed rail network, which connects the bustling cities of Beijing and Shanghai. This bridge is part of the larger Beijing-Shanghai high-speed railway, which significantly reduces the travel time between these two major cities. The journey that once took over 12 hours by car or train is now reduced to about 4 hours, revolutionizing transportation in China and connecting millions of people to opportunities and resources across the country. This bridge, along with the broader railway system, has been a key factor in China's economic growth. By improving transportation efficiency, it has enabled faster movement of goods, tourists, and workers between cities, promoting economic integration and regional development. The Danyang Kunshan Grand Bridge has thus become a critical artery in China's transportation network, facilitating trade, tourism, and communication between key urban centers. The Danyang Kunshan Grand Bridge was built with an awareness of its environmental impact. Construction techniques were chosen to minimize disruption to local ecosystems, and careful planning was undertaken to preserve the surrounding environment. Despite its massive scale, the bridge's environmental footprint was minimized, and its construction involved the use of eco-friendly materials and methods. In areas where the bridge crossed wetlands and rivers, engineers took special care to ensure that the bridge's foundations did not damage the natural habitats. Socially, the bridge has had a positive impact on local communities. it has brought new opportunities for trade, tourism, and business to regions that were previously less connected. The high-speed rail system has also made it easier for people to travel for work or leisure, improving the overall quality of life for millions. The bridge, while a technological marvel, has also played a role in improving the daily lives of those who rely on its transportation system. The Danyang Kunshan Grand Bridge is a shining example of what can be achieved when engineering, innovation, and determination come together. Its construction not only reflects China's ambitious infrastructure goals, but also highlights the role of technology in overcoming complex challenges. The bridge's ability to cross diverse terrains, its innovative design, and its contribution to improving transportation make it a symbol of the progress that modern engineering has achieved. The bridge's impact extends beyond its role as a transportation link. It is a symbol of China's ability to create world-class infrastructure and its commitment to enhancing connectivity across the country. It also serves as a reminder of the potential for human ingenuity to shape the future and address the growing demands of an increasingly interconnected world. As a key part of the Beijing-Shanghai high-speed railway, this unmatched bridge has revolutionized travel and played a significant role in China's economic development. The Danyang Kunshan Grand Bridge is not just a physical structure, it is a testament to the future of global infrastructure and the incredible feats that engineering can achieve. The Hong Kong-Zhuhai-Macau Bridge, a landmark of connectivity and innovation. The Hong Kong-Zhuhai-Macau Bridge, HZMB, is one of the most ambitious and awe-inspiring infrastructure projects in recent history. Stretching over 55 kilometers, 34 miles, this bridge and tunnel system links three major cities in the Pearl River Delta, Hong Kong, Zhuhai, and Macau, making it the world's longest sea-crossing bridge tunnel system. Opened in 2018, the HZMB has revolutionized transportation in the region, significantly reducing travel time between these cities and creating new opportunities for economic integration, trade, and tourism. The bridge stands as a symbol of China's engineering prowess, economic development, and its vision for a more connected future. One of the most remarkable aspects of the Hong Kong-Zhuhai-Macau Bridge is its engineering complexity. The project combines a series of bridges, tunnels, and artificial islands to create a seamless connection between the three cities. The structure includes a 22.9-kilometer bridge, a 6.7-kilometer tunnel under the sea, and a 1.3-kilometer artificial island. The tunnel portion was designed to allow ships to pass through the busy waters of the Pearl River Delta without obstruction, which required innovative engineering solutions to ensure safety and efficiency. The bridge was constructed to withstand the harsh conditions of the region, including strong winds, typhoons, and seismic activity. The use of advanced technology, such as high-strength concrete and steel, as well as state-of-the-art construction techniques, was essential to creating a bridge capable of enduring these environmental challenges. The project also involved overcoming significant logistical and technical hurdles, such as building a tunnel in the sea and creating artificial islands to support the bridge. Before the Hong Kong-Zhuhai-Macau Bridge, traveling between Hong Kong, Zhuhai, and Macau was time-consuming and inefficient. The journey by road or ferry could take up to 4 hours, depending on traffic and weather conditions. With the opening of the HZMB, travel time between Hong Kong and Zhuhai has been reduced to just 30 minutes, while the journey between Hong Kong and Macau now takes only 45 minutes. This dramatic reduction in travel time has transformed the region's transportation landscape, making it easier for people to travel for work, leisure, and business. The bridge also enhances the economic integration of the Greater Bay Area, GBA, a region that includes Hong Kong, Macau, and 9 cities in Guangdong Province, including Zhuhai. The GBA is one of China's most dynamic economic regions, and the HZMB plays a crucial role in connecting its cities and facilitating the movement of people, goods, and services. The bridge has opened up new possibilities for cross-border cooperation and trade, allowing businesses to operate more efficiently and individuals to access new opportunities in neighboring cities. The Hong Kong-Zhuhai-Macau Bridge has had a significant impact on tourism in the region. Prior to the bridge's construction, travel between Hong Kong, Macau, and Zhuhai was often cumbersome and limited by ferry schedules or border control procedures. With the bridge in place, tourism has become more accessible and convenient, benefiting both local economies and international visitors. The bridge makes it easier for tourists to visit multiple cities in a single trip, boosting the tourism industry in all three regions. Moreover, the improved connectivity has contributed to regional development, particularly in Zhuhai and Macau. As more people are able to travel easily between these cities and Hong Kong, new business opportunities have emerged, leading to economic growth and the creation of jobs. The HZMB has also helped to stimulate investment in infrastructure and services, further boosting the region's development prospects. While the Hong Kong-Zhuhai-Macau Bridge is a monumental achievement in terms of engineering and transportation, it has not been without its environmental and social challenges. The construction of the bridge involved significant changes to the region's landscape, including the creation of artificial islands and the alteration of marine habitats. Environmental impact assessments were conducted to mitigate these effects, and various measures were implemented to reduce the bridge's ecological footprint, such as ensuring the preservation of marine life and minimizing the impact on air and water quality. Socially, the bridge has faced some criticism due to concerns about its cost, which amounted to approximately $20 billion, and its potential impact on the communities in the area. While the bridge has undoubtedly created new opportunities for economic growth, it has also raised questions about its long-term benefits and the extent to which it will improve the quality of life for local residents. However, supporters argue that the bridge will eventually have a transformative effect on the region's economy, providing lasting benefits for businesses and individuals alike. The Hong Kong-Zhuhai-Macau Bridge is not only a remarkable engineering achievement, but also a symbol of innovation and collaboration. The project was a joint effort between the governments of Hong Kong, Macau, and China, demonstrating the power of cross-border cooperation in achieving ambitious infrastructure goals. The bridge has also highlighted China's growing capabilities in large-scale infrastructure projects, further cementing the country's position as a global leader in engineering and construction. The HZMB is more than just a transportation link. It represents the vision of a connected future where borders are less of a barrier and cities are united by shared opportunities. The bridge is a testament to the ability of modern engineering to overcome challenges and create solutions that improve the lives of millions of people. While it has faced environmental and social challenges, the bridge's overall impact has been overwhelmingly positive, and it stands as a testament to human ingenuity, collaboration, and the pursuit of progress. As the bridge continues to play a vital role in the Greater Bay Area's development, it will undoubtedly be remembered as one of the most significant infrastructure projects of the 21st century. The Shuman Bridge, a triumph of engineering. The Shuman Bridge, located in the Zhejiang province of China, is a monumental feat of engineering and one of the most impressive suspension bridges in the world. Spanning the Shuman Strait, the bridge connects the island of Jintang to the Zhoushan archipelago, facilitating smoother transportation in an area that was once difficult to access due to the geographical challenges of the region. At its completion in 2009, the Shuman Bridge became the second longest suspension bridge in the world by main span, measuring an astonishing 1,650 meters. The Shuman Bridge's construction is a testament to the advancement of bridge engineering. Its design as a suspension bridge featuring a main span of 1,650 meters was groundbreaking in terms of its structural complexity and scale. The bridge is supported by two massive towers, each standing at 280 meters tall, which are crucial in bearing the enormous weight of the bridge deck and the heavy traffic it accommodates. The bridge deck is composed of steel and concrete, combining the strength of both materials to ensure durability and stability under the challenging environmental conditions of the region. One of the primary engineering challenges faced during the construction of the Shuman Bridge was its location in a seismically active area and the difficult weather conditions. The strait it spans is often subject to strong winds, frequent typhoons, and seismic activity. As a result, the design of the bridge needed to incorporate safety features that would allow it to withstand these forces, ensuring the safety of vehicles and pedestrians crossing it. Advanced technologies and construction techniques such as cable-stayed design and precise anchoring systems were employed to achieve the necessary structural integrity. The construction process itself was equally impressive. The bridge was built using a combination of methods, including cantilever construction, where the bridge deck was constructed piece by piece while being supported by the bridge towers. This technique allowed for the precise placement of each section, ensuring a perfect fit and minimal risk of structural failure. The Shuman Bridge's successful completion is a testament to the skill, expertise, and innovation of the engineers and construction teams involved in the project. Before the Shuman Bridge was built, the Kunshan archipelago, including the island of Danyang, was only accessible by ferries or a lengthy road detour. This made transportation between the islands and the mainland inconvenient and inefficient, limiting the region's economic development. The completion of the bridge significantly improved the transportation network in the region, making it easier and faster to travel between the islands and the mainland. The Shuman Bridge has had a transformative effect on the economy of the Kunshan archipelago and the broader Zhejiang province. It has reduced travel time for both locals and tourists, which has been crucial for the movement of goods, people, and services. With improved connectivity, businesses in the region can more efficiently access markets, supply chains, and resources. The bridge has also made it easier for tourists to visit the islands, boosting the tourism industry and creating new economic opportunities in the region. Moreover, the bridge has played a key role in facilitating regional integration. As a critical link in the transport infrastructure, it has helped to promote trade and cooperation between the islands and other parts of China, supporting the development of industries such as fishing, shipping, and manufacturing. The improved accessibility has led to the expansion of port facilities and an increase in international trade, further contributing to the economic growth of the region. As with many large-scale infrastructure projects, the construction of the Shuman Bridge raised concerns about its potential environmental impact. The bridge spans a vital marine ecosystem, and environmentalists were concerned about how the construction and the ongoing presence of the bridge would affect local wildlife, particularly marine life. During the planning phase, extensive environmental impact assessments were conducted to identify and mitigate any potential negative effects on the surrounding environment. To minimize the environmental footprint, measures were taken to protect the local ecosystem. The construction process was carefully planned to avoid disturbing the marine environment, and the bridge's design was optimized to reduce the impact on the surrounding landscape. For example, the bridge was constructed to avoid interfering with key migratory routes for marine species, and the overall footprint of the project was minimized to preserve the natural beauty of the area. Despite these efforts, concerns about the long-term environmental impact of the bridge continue to be monitored. The Shuman Bridge is not just a physical structure. It has become a symbol of China's rapid modernization and technological prowess. The bridge's impressive scale and design demonstrate the country's ability to undertake and complete complex engineering projects that push the boundaries of what is possible. The completion of the Shuman Bridge is part of China's broader effort to enhance connectivity and regional development. The bridge stands as a symbol of national pride, showcasing the country's engineering capabilities and its commitment to improving the lives of its citizens. It is a reminder of the power of infrastructure to transform communities and create new opportunities for growth and prosperity. The bridge's impressive design, coupled with the challenges overcome during its construction, highlights the skill and innovation of the engineers and workers involved. We're not done. We still have two marvelous bridges in the list. Keep watching. The Runyang Bridge, a monumental achievement in bridge engineering. The Runyang Bridge, located in Jiangsu Province, China, is a remarkable feat of modern engineering that spans the Yangtze River, one of the longest rivers in the world. Completed in 2005, the bridge complex is composed of multiple sections, including a cable-stayed bridge, a suspension bridge, and several viaducts. As the longest bridge in China and one of the largest in the world, the Runyang Bridge stands as a testament to the advancements in civil engineering and infrastructure development. This essay explores the design, construction, significance, and impact of the Runyang Bridge. The Runyang Bridge is an engineering marvel that consists of a combination of different types of bridges. The most iconic section of the bridge complex is the main cable-stayed bridge, which spans 1,490 meters, 4,188 feet, making it the longest cable-stayed bridge in China at the time of its completion. This bridge is flanked by a suspension bridge with a span of 1,410 meters, 4,626 feet, and several viaducts that connect the various sections of the bridge. The bridge complex stretches over a total distance of 35.6 kilometers, linking the city of Yangzhou on the northern bank of the Yangtze River with the city of Zhenjiang on the southern bank. The design of the Runyang Bridge required careful consideration of the geographical and environmental challenges posed by the Yangtze River. The region is prone to strong winds, seismic activity, and unpredictable weather patterns, all of which present potential risks to the stability and safety of the bridge. To mitigate these risks, engineers employed advanced technologies and innovative construction techniques to ensure that the bridge could withstand the harsh environmental conditions. The construction of the Runyang Bridge was an immense undertaking that took several years to complete. The project began in 1999 and was finished in 2005. During this period, the construction team faced a number of challenges, including the need to build the bridge over one of the world's busiest and most unpredictable rivers. The use of floating cranes and other specialized equipment was crucial to the success of the project. The completion of the Runyang Bridge required the efforts of thousands of workers and engineers whose skill and expertise were essential to bringing this monumental project to fruition. The completion of the Runyang Bridge has had a profound impact on the region's economy and social development. Prior to the bridge's construction, the Yangtze River was a significant barrier to transportation between the northern and southern banks. Ferry services were the primary means of crossing the river, but they were slow, unreliable, and often subject to disruption due to adverse weather conditions. The construction of the Runyang Bridge eliminated these transportation challenges, providing a direct, reliable, and efficient route for vehicles, goods, and passengers to cross the river. The bridge has significantly reduced travel time between the cities of Yangzhou and Zhenjiang. Before the bridge, the journey across the Yangtze River required travelers to use ferry services or take a long detour, which could take several hours. With the completion of the Runyang Bridge, travel time between the two cities has been reduced to just a few minutes, fostering greater economic interaction and boosting trade between the two regions. The improved connectivity has had a ripple effect on the economy, particularly in terms of logistics, tourism, and local business. The Runyang Bridge has opened up new opportunities for industries such as shipping, manufacturing, and agriculture by improving access to markets and resources. The bridge has also helped promote tourism in the region, making it easier for tourists to visit the cities of Yangzhou and Zhenjiang and explore the cultural and historical attractions of the area. The construction of the Runyang Bridge required careful consideration of the environmental impact on the surrounding area. The Yangtze River is home to a diverse range of wildlife, including endangered species, and any construction activity could have had a negative impact on the ecosystem. As a result, extensive environmental impact assessments were conducted before the construction began to ensure that the bridge's design would minimize disruption to the river's environment. To reduce the environmental footprint of the project, the construction team implemented measures to protect local wildlife and the river's ecosystem. For example, the construction of the bridge's piers and foundations was carefully planned to avoid disrupting sensitive areas of the riverbed. Additionally, the bridge's design was optimized to reduce the amount of material required for construction, which helped minimize the environmental impact of the project. In terms of engineering, the Runyang Bridge features several advanced technologies that enhance its durability and safety. The use of high-strength steel and reinforced concrete in the bridge's construction ensures that it can withstand the weight of heavy traffic and resist the forces of wind, water, and seismic activity. The bridge's design also includes features such as anti-corrosion coatings and specialized monitoring systems that allow engineers to track the condition of the bridge over time and make necessary repairs or adjustments. In addition to its technical achievements, the Runyang Bridge represents the country's broader economic and social transformation. The bridge has facilitated greater regional integration, allowing for the easier movement of goods, people, and ideas between different parts of China. This has helped foster economic growth, reduce regional disparities, and promote a more interconnected society. The bridge also stands as a symbol of China's growing technological prowess and its ability to execute large-scale infrastructure projects. As a key part of the country's modernization efforts, the Runyang Bridge continues to serve as an important transportation link, driving economic development and connecting communities across the Yangtze River. The Sutong Bridge. The Sutong Bridge, located in the Jiangsu province of China, is one of the most impressive engineering feats in the world. Spanning the Yangtze River, this cable-stayed bridge connects the cities of Suzhou and Nantong, facilitating efficient transportation across one of China's busiest waterways. Completed in 2008, the Sutong Bridge stands as a testament to the advancements in bridge engineering, design, and construction. It is not only a critical infrastructure project for the region, but also an iconic symbol of China's rapid modernization and its growing technological capabilities in civil engineering. The Sutong Bridge features a cable-stayed design, a type of bridge where the roadway is supported by cables connected to towers. With a main span of 1,088 meters, it was, at the time of completion, the longest cable-stayed bridge in the world. The bridge's total length is approximately 8,206 meters, 5.1 miles, and it stands 100 meters, 328 feet, above the river, allowing for the safe passage of large ships underneath. The central tower, reaching a height of 306 meters, 1,004 feet, is a prominent feature, making it one of the tallest structures in the region. To overcome the challenges posed by the wide and fast-flowing Yangtze River, engineers utilized advanced construction techniques and cutting-edge materials. The design took into account the river's strong currents, seismic activity, and environmental factors such as wind. The use of high-strength steel and reinforced concrete ensured that the bridge could withstand heavy traffic loads and extreme weather conditions, while the aerodynamic shape of the bridge reduced the impact of wind forces, ensuring stability and safety. The Sutong Bridge has had a profound impact on the economic development of the region. Prior to the construction of the bridge, the Yangtze River was a significant barrier to transportation between Suzhou and Nantong, two rapidly growing cities in the Yangtze River Delta. Ferry services were the primary means of crossing the river, but they were slow and often disrupted by adverse weather conditions. The Sutong Bridge has eliminated these issues, providing a fast and reliable connection between the two cities, significantly reducing travel time and enhancing the efficiency of transportation. The bridge has played a crucial role in boosting trade and commerce between Suzhou and Nantong. With improved connectivity, goods can now be transported more quickly and efficiently across the river, benefiting industries such as manufacturing, logistics, and agriculture. The Sutong Bridge has also contributed to the development of tourism in the region, making it easier for visitors to travel between Suzhou's historical sites and Nantong's cultural attractions. Furthermore, the bridge has fostered greater regional integration, encouraging economic cooperation and collaboration between neighboring cities and provinces. The construction of the Sutong Bridge required careful consideration of the environmental impact on the surrounding area. The Yangtze River is home to a diverse ecosystem, and any large-scale infrastructure project has the potential to disrupt local wildlife. Before construction began, extensive environmental impact assessments were conducted to ensure that the project would minimize harm to the river's ecosystem. The bridge's design incorporated features that reduced its environmental footprint, including the use of sustainable materials and construction techniques. In terms of structural considerations, the Sutong Bridge had to be designed to withstand the unique challenges posed by the Yangtze River. The river is known for its strong currents, particularly during the rainy season, which could have affected the stability of the bridge's foundations. To address this, engineers employed advanced techniques for foundation construction, including the use of deep water pile foundations that could anchor the bridge to the riverbed securely. The use of high-quality materials also ensured that the bridge would be durable and resistant to corrosion, especially given the region's humid climate. The Sutong Bridge is not only an important transportation link, but also a symbol of China's growing technological prowess and its ability to execute large-scale infrastructure projects. The construction of the bridge required a combination of innovative design, advanced materials, and cutting-edge construction techniques. The bridge's impressive size and structural complexity showcase the country's capabilities in modern civil engineering. As China continues to develop its infrastructure, the Xiang Bridge stands as a shining example of the country's commitment to improving transportation networks and enhancing regional connectivity. The bridge's completion was a significant milestone in China's broader efforts to modernize its infrastructure and support its rapidly growing economy. It has also served as an inspiration for future bridge projects, both in China and around the world, demonstrating the potential of cable-stayed bridge design and the use of advanced construction methods. The bridge is a symbol of China's growing technological capabilities and its ability to undertake large-scale infrastructure projects. As a critical piece of the country's transportation network, the Xiang Bridge continues to play a vital role in promoting economic development and regional integration. Wow, you've reached the end of the video. Those bridges were sure impressive. Like and share the video, and we'll see you in the next one.